Okay, I think we're good to go. So, hello everyone, my name is Mayank Pandey, and I present to you my project Window Dating. Now, what is window dating, you ask? Very simple. It's basically a platform, pretty much like Tinder, but console based. So, you know how Tinder is graphical user interface based, and you have all fancy graphics. Well, I was like, nah, let's go back to the primitive technology and make something console based because no one likes anything better than plain text with no colors. Yeah, I know. Exciting. So, alright, let's get on with it. And in this video, what I want to do is I want to demonstrate what my project does and how it does that. And what were some of the concepts that I had to use to make this happen? And what were some of the features that I had to utilize? And some of the nuances of programming and object oriented features, basically, yeah, that I used. So let's go ahead. So this is my code editor. This is called Atom. And as you can see on the left hand side, I have all of my files that I used for making this project, right? But before I dive into each and every file, I want to give you a general idea of how it is structured. And it's not too complicated, but it's a little bit involved. So stay with me and you'll be fine. So if you are on Tinder, what are you looking for? You're looking for people to chat with or like perfect matches. And basically the idea is you're looking for people at the end of the day. So you're looking for a bunch of users, and these users have registered on the app just like you, right? So you probably came in and you registered with a bunch of details of your own. You have a first name, you have a last name, you have a phone number, you have an email, you have age, you have a gender, right? You have all of those nifty details, and so do all of those other users already on the app. So basically, at the end of the day, Tinder is just a collection of users, and users is basically people, right? So that's basically a gist of what Tinder is, and my window dating is really similar to that. So that should give you a better idea of what I'm doing. I'm just making a collection of users that are people, right? And then I do some operations based on their details and or on their preferences and stuff like that. That would be more into the detailed part of it. So to start off, I'm using features like encapsulation in this project. I'm using inheritance, polymorphism, static members and functions, friend functions, overloaded operators, and text files to make this project happen. I am using not one, not two, but 6 different classes. And these classes are the person class, like I told you, every person. And then I have a student class for a user which happens to be a student. Then I also have a standard class for a user that happens to be a standard user and not a student user. And then we have a user class which makes the user of from like either student or standard, right? Then I have a user list class which basically holds a bunch of users. And then I have the user IO class, which is basically responsible for input output. So it's reading from a registrant's text file for reading in whatever the users have been registered so far, or writing to that file whenever a new registration happens. And we also have another text file which is called likes. So on Tinder you can right swipe or left swipe. Similarly, on my app you can hit or miss. I bet you never miss, huh? So so basically the idea is that you hit someone, and then if they hit you back, then you guys match. Very similar. That's the same concept Bumble uses, that's the same concept Tinder uses, and so many apps in the market. And so to do that, I am utilizing this text file called likes, where basically I store in the person who liked someone. So let's say A is a person and B is the person that A likes. So on my app, A would hit on B, and then that data would be transferred to the likes file in a way that it would say that A space B. So it's like two columns. Imagine two columns. The first column is A, second column is B, right? Now later on, let's say B happens to like A, which is pretty cool. It doesn't happen that often, but let's say it happens. So this time around, the data that goes into the file is B in the first column and A in the second column. So now you see that A in the first column and B in the second column for the first row, and now in the second row we have the reverse of that, which basically tells my app that, hey, this person like that person, and oh, that person like this person, so tell them that they are a match. And that's basically what it does. So that's why it is using the likes.txt file. So that's text files. That's a basic idea of why text files are being used in this application. User list class is basically a collection of users, right? And user is inheriting its data members and its member functions from standard and student class, which are inheriting from person class. And now to show all of that, I'll start with person. So a person, a regular person has a first name right here. A regular person has a last name. Pretty sure they do, because I do. A regular person has an email. A regular person has phone number, age, gender, and all of those details and many more. But for now, we're just taking these 6 data values for a person. We are going to take more inputs from the user, that is registering. But as a person, these are the details I believe they hold. And so what I'm doing here after this, basically in my class for this person, what I'm doing is I'm giving it these private data variables. Why private? Well, for security and privacy of these classes, which is like a really good design structure, and basically to also promote encapsulation. What is encapsulation? Well, that's what we're getting right into it. And if you see down in a public section, we have a bunch of functions. What are these? These are setters and getters. What do they do? Well, you see this function set first name, it takes a parameter, right? It basically does this. Let me open both of these so that you can have a side-by-side view of what is happening. So person.h is basically the header file. Person.cpp is basically the implementation file that that has the definitions for each function, right? So this is the declaration, this is the definition in a way. So you can see that first name is basically setting the first name variable right here to the value that is being fed to it in its parameter as an argument. So where does that happen, you ask? Where is it getting this value from? Well, that is happening in the main file, but that's for later, one step at a time. First, let's find out what's happening in general and how we are making these classes and how we're making objects and how we are utilizing these in classes first. So yeah, so first name is being set to the parameter that's been given, and then we have another function which is called get first name. Get first name is just basically sending the first name back to whatever called it. So it's returning the first name, right? And then set last name is doing the same thing. It's getting the parameter, it's setting the value to last name variable over here in the class. So it does that for all of these. And yeah, it does that for phone number, set age, set gender, get gender, right? It's doing that for all of these. But you notice this one function, virtual void set description equals 0. This is basically a function that makes this class abstract. Why is this abstract class, you ask? And what is an abstract class? Abstract class is basically that you cannot instantiate this class. You cannot make a object of this class. And that is really important because, I mean, why would you make a person object when you can make a user object? No, that was a really bad logic. But basically why I'm making this a person class, an abstract class, is because I have other classes that inherit from this. So it's not a standalone class. It is helping other classes to get these data values and then do something with it, right? So it's a big picture. And so to do that, this is the function that I'm using. And basically, whichever class gets this function is going to implement it and override it, basically. Yeah, that was the word I was looking for. It will override it. So you would see that in this one, CPP, personal CPP, we don't have a definition for that one. Why? Because it's an abstract class. We do not provide an implementation for the abstract class method. Otherwise, what's the point of it being abstract? So an abstract class, basically, yeah, it is just a class which has one pure virtual function. So that is a pure virtual function because it's been set to 0. Well, enough about person class now. So you get the idea that yes, we have a person, but what do we do with a person, right? We just have a person, but that's where the student and standard classes come in. So let's say you registered and you are basically either a student or a standard user for my application. So excuse me for that. So a standard user and student user, they share a lot of details, right? That's why I'll like to show you standard.h first, which is the header file for standard class. So right here, if you see, standard class is inheriting the person class, right? So it inherits all the data members and all the member functions from person class. Now, it has data members of its own too. So like besides the ones that it got from person, like I told you, we'll get more and more stuff from the user, even though it's not part of the person. So the other data that we are planning to get is genres of music that they like, music genres that they like, yeah. Their biography, what do they have to say about themselves, their sexual orientation, are they heterosexual, straight, basically, or any other orientation. What is their descriptions, basically? Description is just my way of saying what's their profile card like. When you have a profile, you have all sorts of stuff on that card. When you look at Tinder, you find this person. This person has a name, age, their biography. They have like their songs on Spotify that they listen to, or like the things that they've been interested in, like hobbies and stuff like that. So basically, description gives you a card for each user, and this description in particular is making it for the standard user, right? There are other things coming in for student users. I'll just show you, but let's stick to what standard user has in store for us. So next thing we have are some of the setters and getters again. Set genres, get genres, set bio, get bio, set orientation, get orientation, set description, get description. You would notice this set description and the one in person.h are the same. So that shows you that standard.h is basically inheriting that function and overloading it such that now this is not an abstract class, right? This is polymorphism. Yeah, this is polymorphism. And so to that end, in my CPP file, you can see setters and getters. Again, they get a parameter. It sets the value of the data member of that class to the parameter or the argument, basically. And then it has get genres. So genres is a vector of strings. That's why its return type is a vector of strings and not just a string, because you see people have many preferences when it comes to genres. I personally like rock, classical, casual, folk, spiritual, ambient, a lot of music. I am a musician, so I like a lot of genres of music. But enough about me. Let's get on with set bio. Same thing, it gets a argument from, let's say, a magic world right now. We don't know where it's getting it from, but it's somewhere in main.cpp. So let's just imagine it gets it and it sets it to bio, the bio variable in our class standard. And same thing, it is the getter returns the value, setter sets the value, getter returns the value. Now this is the interesting part. This is overloading set description function of person class, right? So set description, this is where we're making the card, like I told you, like a user card. So user card has a name, which is basically get first name, get last name. This is where we are utilizing these getters we have been writing. So many getters, but for what reason you must have been thinking so far. But this is the golden reason. See how nice it looks, how clear it is, and how this is implementing encapsulation. This is a really good example of implementing of encapsulation, data privacy. So next thing we have is age. We have the name, we have the age, we have gender, get gender, bio, get bio, orientation, get orientation, and genres music, get genres of music, and then we get the genres of music in a vector, but when we are printing it, we are printing it with like comma separated values. So this is like a logic for separating it with commas. The reason why one of these is outside is because I didn't want to put a comma after the last genre. So let's say you have like rock. I'm gonna comment this out. You have rock, then you have classical, then you have funk, and let's say the last one is R&B. But after R&B, you still have a comma and a space. That doesn't look good. So we would like to have it this way. That's why it's outside. And then get description is just returning the description standard variable. We just set all of this too. So that's the standard basically class, right? Then there's a student class, which is also inheriting from person, and it's getting all the data members and all the member functions from person. But like I said, it also has some of its own. A student has a major, a student has a school year, and a student has a school, like the name of the school. He doesn't own a school, he just has the school's name. So again, same scene. We have setters and getters. Set major to whatever the parameter is, get major, set school, get school, set school year, get school year. So let's go into the implementation file because it's really small. We're just using setters and getters for this one. Setters and getters, setters and getters, right? Simple stuff. Now, student, standard, person. We have 3 classes that have been done so far. Out of the 6 classes, we are done with 3 classes. What comes next is basically a question, but if you look at the hierarchy, right, you have the person, and then you have these standard and student classes. Imagine with me. Imagine that there's person at the top, and then you have standard and student, which are inheriting from this, right? So what comes next? What comes next is basically user, which inherits from standard and student, right? And then it also has like data members of its own and member functions of its own, right? Because we are always adding to something. So in that sense, a user has a type, a user has a password, and a user has a description. This description is going to be the final description, whether they are a student or a standard user. And so this is where the magic is happening. So we are making we are making a user object, right? And this is the constructor for making that user object. And this one in particular is, as you can see, for a standard user, and the next one is for a student user. The difference is in the number of parameters it's getting. It's getting a lot of parameters. I know there are so many parameters, but yeah, so that's what differentiates. And this is constructor overloading. We are using a constructor with different number of parameters, which basically is overloading the constructor, right? And this is all in the implementation file. I'm just going to go through this really quickly so that we can go and see a little bit more on the implementation side. Then same thing, setters and getters for type, for password, for description. And now this is something new. What is this? This is operator overloading. Operator overloading is basically, um, it's basically we are using the operator, this operator, and we're defining a new purpose to it. Not a new purpose to it, but we're defining functionality for something that it doesn't expect. So usually you would use this to print something onto the console, like cout, and then this. Let me give you an example pretty quickly. You would do something like cout this operator and then say hello, and this would print on the screen. But let's say if you're saying cout user, well, the console doesn't know what to say. It doesn't know what you mean. How do I print a user? It's not defined. So operator overloading is allowing us to do that for the system and make sure that the implementation is how we want it to be, right? So that is in the user.cpp file. This is the constructor for standard user, and whoa, it is big. For student user, it's even bigger, but let's go line by line. So the parameters that this is getting, right? The constructor for the standard user is getting the first name parameter, last name parameter, email parameter, phone number, age parameter, gender, genres, bio, orientation, password, and the type. And then what it does is basically it calls all of those setters in the person class and also in the respective student or in the respective standard class. Excuse me. And the standard class, because this is for standard user. So this is from person class, this is from person, this is from person, again person, 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 and this is standard. That's where the standard starts. So basically, yeah, calling the setters for each value and just sending in those parameters that we are getting. Where are we getting these parameters from? From main, where the app is functioning, where we are logging in or we are registering, or we are reading in from text files. That's how we get the data, right? Either from the user or from the text file. We don't magically generate data. So that's enough for standard user. And then this final thing, the set description, which is down here. We'll go through it later, but this is basically where we are making the final profile card of a user for standard or said student. So for the student constructor, same thing: first name, last name, email, phone number, age, gender, genres, bio, orientation. Now it's different. After orientation, now we have major parameter, whatever the major they have, whatever school year they're graduating in. Let's say 2023 for I think most of us here in this class. School parameter, let's say University of South Florida for most of us again. I mean, password type, yeah, and then same story. It's just calling in these setters with the parameters and it's making it, and then setters and getters again. The usual story, but this is new. Cell description. What is set description doing? It is overloading this function from person class first of all, right? Then what it does, it gives a call to the set description function in standard class. Standard class, huh? What was that doing? Well, that was making a description string for a standard user, right? With name, age, gender, bio, orientation, music genres, right? So it calls that. It calls set description. So now description standard string has all this. And then it says DESC, sorry, which is the data variable for this class, user class. It gets that description. Now it is getting that description from the standard class, which is basically a call to this function that is returning this thing, which we just set everything to in this class. So now that we have all of that in DESC, we do one last check because we already have the description for a standard user. So if we are standard, then we are done. But what if this dot get type, not that dot, but like the arrow operator, and because this is currently calling object, and then we want to see if this user object's type is student, which might be. And if it is so, then we want to say, okay, add these two details or three details to that description. First of all, add the major, get major, new line, school and year, the school and the school year that they're graduating in, and a new line. So that's how we are making this description profile card for students or standard users. And then get description is basically returning that description we just made. Operator overloading for that um, output operator basically. It's a friend function of OStream, right? OStream is basically what is being used to print out of the console, right? And it also gets the user object, right? So user object is basically whatever object we are dealing with right now. So let's say, hey, on the main CPP, we're not there yet, but the main CPP we are talking about the current user. We want to see what the current user is like. So we could just say, hey, current, let's say, put on a comment here, current user, oh sorry, see out current user. So now it will know what to do because we're defining the implementation, which is basically saying whenever it is being called, just get the description of the user and print it. And endl is basically the next line and just return that. So that's how it works. Very simple and very easy. So that's basically the user class and what it is doing. It is inheriting standard and student classes and using their functions and its own function members and operator overloading to make all of this work and make sense out of the data it is getting. That's how we are making a user, right? So let's clear the canvas. Now we have a person, we have standard and student, and we have a user. What next? Well, what if we have a bunch of users? That's what's next. Because yes, in an app like this, we have a bunch of users, and that's where, not this, this. That's where its user list comes in. It is composed of user objects. So it has data members of its own, and it also has like member functions of its own. For data members, it has a user's vector, which is a vector of user. So each member is a user, and it has two variables for the count of student and for count of standard, right? It's like how many student users there are and how many standard users there are. Then the functions that this class has are like it has a operator, like it has two operator overloadings, but let's get down to the first one, which is a plus equal to sign, which is basically saying, hey, we can add users to this list using this operator, right? So we are again we are defining functionality for this, because if you were to go and say, hey, add this user to this list, that would not work. The reason that would not work is because again the computer or the console doesn't know how that works, right? And so we'll be defining this in the CPP file if you're wondering, just in a moment. But that's basically what we will be doing with this function, and that's what it is being used for our for our ease of access, for our ease of functionality. We're just making, okay, this operator should do this without making any functional stuff. And it is also a form of polymorphism, if you're wondering. This is compile time polymorphism. Then another operator we are overloading is the brackets, which are for accessing each user in the vector. So let's say we wanna I'm gonna comment down here again. Let's say we wanna access the user at index 3. Normally that would not work. Why? Because we don't have implementation defined for it. But now with this operator overloading, we know what to say. We know what to send it. Because user is not a defined type, right? We are making this ourselves. So we got to define the implementation for its access as well. Then we have some standard functions like get size, which is basically returning the size of the user's list. Get count students, which is returning the number of students we have. Get count standard, which is returning the number of standard users we have. Now the question is, wait, how is it getting these values for count student or count standard, right? because we are not using setters here. There are no setters to make this happen, right? So how's it getting this? We're not sending any parameters. What's going on, right? Excuse me so much. Whoa, what's really going on here? So that's where this next line comes in. We have a friend function to update the count of student and standard users. So this friend function is basically being sent a user list such as this, and then it does something. What does it do? Let's go to the userlist.cpp to find out the implementation of all of these. So like I said, plus equal to operator. It does nothing but this one line. It says, hey, users vector, push this user we are getting right now. Very simple. So when you say list, let's say you have a list which is named list, and then you say plus equal to user, this is what is happening. It says users.pushback user for that class. Same thing with the access operator. It basically says, okay, it gets an index like 3 whatever, that was the example in the last file. It says return the the user at that index in the vector. So it's using that for this operator, right? Very simple stuff again. But now we are defining what we wanted to do. So now it makes sense for the compiler, for the console to know what's going on. And then we have the friend function definition, count. So it says this. So it gets a list, right? We read in a list, let's say, from the text file, and we have a list of all the users. We have all the users that have registered so far. We send that list to the count function. What does the count function do? It says, okay, first of all, it's 0. Everything is 0. We don't have any numbers right now. But then we go through the list. We loop through the list, and we say, okay, if the student is if the user is a student, if list of i.getType, if their type is student, then increment the student counter. If not, then obviously increment the standard counter. And that's how we are getting the count of students and the count of standard. So that covers that. But then we have one more class to go. What will that be? Well, yes, you're right. We have all these users. We have a collection of users, but what do we do with them? If we terminate a program or like a console, we lose all these users. So what about next time? Yes, we got to store these users somewhere. That's where the text files come in. And to deal with those text files, we have the user IO class. This is the header file for user IO. Let me close all the other classes for now. User IO, right? 4 static functions. It doesn't have any data members. It has 4 static functions because these are class functions. You don't need to make an object for a user IO. You can just use the class. So the first function is basically, it's self-explanatory. It says read data from the registrants file, and the data type for the return is user list, because we are reading in from the file, and you don't find one user, you find a bunch of users. So you make a list out of them, and the user list file, the user list class just comes so handy for that, and then returns it back in that the data type, right? Sorry about the commotion outside. I have roommates that are a little loud. But yeah, so the next thing is write data registrants, which is basically writing to that file. This is the same file we are now writing data. So it is being sent a list. A user list is being given to this function, right? You're sending in a list of like maybe a new register that has a new user that has just registered, right? And we want to say, oh, we found a new user. Why don't we store it in the registrants file? So this is what this one does. So that's the function of these two. First one is to read from that same file, and the second function is to write to the same file whenever we have new registrations. And reading is when we have like operations happening, right? Then third function, this is fun. This is the read data from the likes file. So we have a likes file, right? And we are saying, okay, we want to read in data from the likes file. But what does it do? Why does it have such a such a complicated return type. Its return type is a vector of a pair of strings. So a vector of a pair of strings. So each pair has two string values, and then that pair is being added to the vector. How do we come up with these pairs, and why are these strings, and what is this vector? That all comes in the implementation file. But let's move on to the next function, which is write data likes. Again, same thing. We are now writing to the same file we were reading in the third function. So now we want to write to this file. When do we want to write to this file? Whenever a person hits. So okay, person A hit on person B. But if we don't store this information, it just gets lost. We have no way of recollecting if we don't store it, right? It's not like we can access like, oh no, this happened in the past. No, if we don't store it, it's gone. So that's why we need to write to the file. That's really important. And now let's go to this implementation file and find out what's happening. All right, we are in the implementation file for the user IO. And the first function we find is read data registrants. What is read data registrants, you ask? Well, yeah, it's reading from registrants file, like I said. So it's opening the registrants dot, excuse me for that, for the text file, and it's declaring a user list because we're going to use this list. String streams SS because we're going to read a lot of values from the text file, so we've got to make sure that we are able to parse all the information that we're getting. Then we have a few vectors. This details vectors, parameters vector, and music genres vectors. Well, the music genres vector is pretty self-explanatory because we have multiple genres, but what's up with parameters and what's up with details? Well, parameters is basically all the values that we get in from line, but it may not be exactly like what we need. Maybe we don't need certain, like we don't need the data in the way it is being presented in the parameters vector. And basically, why am I using a vector? Because it's easier to like store all those. Okay, at 0 we have that, at 1 we, at the first index we have this, at the second index we have that. So for that reason, and so that's where the details vector comes in. It is parsing all the information in parameters vector already, and separating it out or segregating it in the way we want it. The way we want is prescribed by how we wrote our constructor function, constructor for the user class, right? So that's where the format comes, the prescribed format comes from. Yeah. So basically, we open the input file, and we're checking if the input file opened successfully or not, because it might have been, it might have had some error opening this file, and if it did, then we have a else block where we're saying, okay, throw runtime error, could not open this file. So we have that caught up. We know what we have to do with that. So we're clearing all of those vectors that we have at the moment, and then we do the usual thing. We get the line from the input file, so we read in each line, we add it to the ss.str, go through, and then we do another loop, and we go through each data in that ss stream, and then we add it to the parameters vector, right? So we are reading each tab separated data, and we are adding it to parameters, and we are incrementing I. I is basically a way of me to keep track of the index that is happening. And then we go ahead and we say, okay, using parameters vector to separate data as per our need for the constructor of a user class and adding it to details vector. Oof, that's a lot. What is happening? We're going through parameters. We run a loop from 0 to the size of parameters, and we go through it. What is I equal to 0? What is I equal to 5? I'm so sorry about the commotion outside. So yeah, basically, I equal to 0 is basically for the name. If we, what is happening is in parameters we're getting like the full name, so we are segregating it into first name, last name, and then we're adding that to details. and I equal to 5 is basically music genres. We're getting music genres, but we don't have it like separately. We have it like in comma separated values because we wrote to the file in comma separated fashion, in a comma separated fashion, which will be shown right below this one, because we are writing to this file later on, right? First we are reading it, and there's also a function for writing this file. So when we are writing to this file, we wrote the genres in a way that we had like rock, comma, space, classical, comma, space, R&B, and stuff like that. But music genres is a vector, so we need each data separately, right? So we need rock, and then the second index, the first index, we have like classical. Second index we have R&B, right? So that's why we are segregating that data. So we're making another string stream SS2. We're seeing if SS2 is good, then we get a line. We get each word from that. Get each word from the stream, and we do a little bit of trimming from front and from back, and we just get a substring of it so that we just get the data and not any spaces at the back or at the front. I think in this case I was getting a lot of space in the front for some reason. So that takes care of that, and then we just push every other parameter in details, because every other parameter is fine. So just putting it in details. Now the next thing that comes in is to check if the type of user we have is standard or student. Why this thing? Because we have all the details, right? But the last detail we get is the type. As you have seen so far in my user class and everywhere, the last parameter is a type. So we are saying, okay, the last index, what is the value at the last index of this vector? If it's standard, then we make a standard user object. We are creating a standard user object, which is done with the constructor format of a standard user, like these many details and whatever. And then we add that user to the list. Else if we make we say, okay, is it a student, right? Because if it's not standard, it's student. And then we make a student object. Student user object has more parameters, so obviously it's going till index 12. But the idea is basically the same. We have music genres and we have like details. Like this is first names, second, last names, email, and so on and so forth. And same thing, we are adding to the list. And then once we are done with this loop, we're just closing the file, because we have to close the file. And now that we have made the list, we just say, okay, return the list. This return list is basically because we are reading in from the text file, so we read in a bunch of users. We add all those users to this list, and now we are sending this list back to main.cpp, where all the magic is happening for now. Let's call it magic for now. Then we have write data registrants, right? So write data registrants is basically opening the same file, and see, it's opening it for iOS app, which is basically it's appending to the file. It's adding to the file, right? It's the data is already there. It's just adding on to that file. How does it make the data to add to the file? First of all, it is opening the file again. If it opens successfully, well and good. Go ahead and do the operations that are required. If not, throw a runtime error which says, okay, unable to open the file. We have that catch going on for the error. So for the exception, I mean, yeah. So for getting that line of data that we are going to print to the to the text file later on, let's see what is happening. We are running a loop till length. What is length? We got the user list from the user at main or somewhere, right? We just got a user list. We are looping through this user list because we want to extract all the information. So we loop through it. We say, okay, making a line of data for whatever type of user we get, because different user, because standard user has a different line of data and the student user has a different line of data because the number of parameters are different. So the length of their line would be different. So let's say line. So now the line is registration list I. So we're looking at the user at that particular index, and we're saying, okay, let's get their first name space, their second last name, give a tab space. So these are tab separated values, right? So these are tab separated values. Then the second thing is, okay, we got first name, second last name, tab separation. Then we have email, tab separation, phone number, tab age, tab space gender, tab space. Okay, after that we have the genres. So we are looping through the genres again, and we are doing this thing with the comma space, and then like I told you, we didn't want a comma after the last one, so we are doing this hack, we could say, where we are stopping it one step before the actual stoppage. Like one index is left off, and that index is being taken care of right here. And tab separation, when the genres are completed, we give a tab separation, we do biography, give another tab space, we get orientation, another tab space. And now after that, if the user at that index is standard, then we just add password, tab separation, and the type. And then we add and then we print this line to the file. So output file line standard ENDL. But if this user is a student, then we got to add a few more details before we can add in password and type. We got to add the major, you have to add a school year, you have to add the school, and then password and get type. And all of these are separated by tab spaces again. And then yes, after that we're just writing to the file. We're writing to the file. Then we're closing the file once we are done with the loop. We're done with the loop here, close the file, and that's good enough for write data resistance. We have two more functions to go though. We have read data from the likes file. What is read data from the likes file? Read data is from likes file is basically opening the likes file, string stream again, getting the line, doing the usual stuff with str, str, reading the tab separated values, putting that in parameters, vector, and then we gotta make the pairs of likes and adding them to the emails vector. What is that? What is basically that? So we got a bunch of users, right? But what we want to do is we want to make pairs of those users. Why we are making pairs? Because it's easier when we are using those values in the implementation, because we could just say, okay, this value dot first, this value dot second, because that's how pairs work. The first value is the dot first, and the second value is dot second. So basically, for easy implementation, we are using pairs. So we make a pair of parameters 0 and parameters 1. What is parameter 0 and parameter 1? The value at parameter 0, which is column A and column B. So this goes back to what I was talking about with A and B in being column 1 and B and A in the second row being in column 1 and 2 respectively. So what is happening is column A, the first column is for people that are the current user right now. Let's say user A is currently the user logged in and swiping through all these like users. So in column A, that's where the current user goes, and then column B is the person that they are hitting on. So let's say A hit on B. That data would be translated in a way that, okay, let's say A email in the first column, and the second column is B's email, right? So that's basically the whole scenario where we're making, okay, emails dot pushback, make a pair of the first email and the second email. So first email is the current user, second email is the person they liked or hit on basically right now. So that's how we are making all those pairs. And then once we have made the pairs, we close the file, close the input file. So we have read in the data. So there were so many configurations of like, okay, A liked B, B liked A, B liked C, B liked D, B liked E. So it made a pair of all of those, and it added all of those pairs to this vector, which is called emails. And so when that's done, it just returns that emails vector of a pair of strings. And write data likes. Now to the same file, we are writing the email of a user and we are writing the email of the person they liked. We open the likes file, same thing, we are appending to the file, We opened the output file, opened successfully, well and good. Didn't open successfully, unable to open a file, throw a runtime error. Let's say if the file opens successfully, we make a line of the email pairs. How do we make a line for the email pairs? We take the email of the user, give tab separation, and say email of the liked person. That's what I was talking about with the columns. So it's not really a column, but it's a good way to visualize what is happening. So first thing, we have the email of the current user, then we have the email of the person they liked. So it could be like the person logged in, right? And then they liked every person. So it could be like A B, A C, A D, A F, and I don't know my ABCs. It just goes on and on. So it could go on and on till the number of users that are in a database, or whatever their daily limit could be in something like Tinder or Bumble. They have like limits if you are not a premium user. So that's that, right? We make a line and then we write that line to the file. And then once we have written that line, we give a new line character and then we close the file. And that's the end of that. So with that, we have covered our person class, we have covered standard class, the student class, and the user class, the user list class, and the user IO class. In all of these, the person class was an abstract class. The standard class was not an abstract class because it was implementing the overloading the set description function, so it is no longer an abstract class. The user is also implementing or overloading the set description, so it's not a abstract class. But student did not implement or overload the set description class, so it's still an abstract class. User class, like I said, it's not abstract. User list is not abstract, and user IO is not abstract. So this is basically the structure of all the classes that I have and what they do, what they have, the data types, the data members, member functions, and what all of it makes sense for, or like what they are doing with, and the purpose of each class, and purpose of why they are and what they do is why they are being made and why they are being used. So now comes the main part. And rightly said, the file name is called main.cpp. Now we are bringing all of those things together. We're saying, okay, include person.h, include standard.h, include student.h, include user.h, user list.h, user io.h. We are adding all of those classes we just made, and now we are going to incorporate them in such a way that we can make an app out of this. We have components. We have made those components, and now it's time to bring them together and make an application. If you know about React, it's very similar. We're making an application based off of components. So in this app, we basically have a bunch of functions. We have, let's say, first one is for the app view. App view is basically, let me give you a basic rundown of what it is. Once the user is successfully able to register, or if he's successfully able to log in, they get to view the app, or what is like the app structure, basically with the users being thrown at them, hey, hit or miss them. And then we have some other function that I'm using to help me out in this endeavor to make this app work. Remove dup word is basically to trim off the spaces at the front and the back of a word. So like from both ends, we are trimming the spaces. Validate string, validate number, validate string with spaces, is email valid, validate password, valid phone, are all functions that I'm using for data validation. So because we are going to throw exceptions, we will be needing to like validate the data. So in order to validate this data, the main part that is important is to use functions that can understand when, okay, this is happening, this is not what is supposed to happen, so okay, throw this logic error or throw this runtime error. So that's what I'm using these functions for, to make sure that the data that I'm getting in through the user is in fact valid and ready to use, ready to implement. So let's start. We go into the main function. This is responsible for the main menu that is first shown. What is that like? Let's see, let's find out. See out window dating commands. We have 3 commands at the starting. We have R, which is a register. We have L, which is for login. X for exit. And then we say, okay, flag is true. This is basically checking if the user entered X and wants to exit. If the user entered X, then they want to exit, right? So flag is basically being used to verify that they want to exit. Exists, to check if the user with the email or that phone number already exists. Sometimes the person could be making multiple accounts with the same email or same phone number. So we gotta find it out and be like, oh no sir, you're making another account with the same detail. We cannot let you do that, because that should not be allowed. That's illegal. And then we're making a user list for list and user list for users. What are these and where are we using them? Let's find out. So we start with loop. We start with this loop. We say, okay, we ask for a command. We showed these options to them. We're asking for a command input now, which is right here, input, which is character input. Character input. We get the character input. We make a genres vector, and then we read in the data from the registrations file. We're reading in from the registration file, and then we're checking the input. If they entered R, that means they want to register. So now we'll start with the logic of registering the user. We say, okay, you want to register, now enter your details below. We take in the first name, given the first name. We validate if it's a valid first name. If it's not, then we just throw a logic error, hey, enter a valid first name. Then we take in last name, same thing, validation, email, validation. And also, this is the validation for if it's a valid email. This is using regular expressions for that. I'll show you the implementation later. But yeah, it's using that. But then there's also this, checking if the user already exists with this email. So what we're doing is, we did this. We got all the users in this user's user list. How we did that? We called an user IO and we said, okay, read data registrants. And if you remember, this function returns a list, a user list, and we declared users as a user list before. So users just takes in all of the it gets the list of all of the users that have already been registered so far. And so over here, what it does, it loops through that list and says, okay, if you find a matching phone number, then we gotta say, okay, this phone number already exists. Or I was at email, so basically, but the same thing for a phone number as well. So we go and say, okay, this email already exists. Then okay, we gotta say exists is equal to true, and if it exists is true, right here, then we make exists false and we continue, because we want to let them know, okay, this email already exists. You can try to register again with some other email, right? We don't want to throw them off because oh, wrong email. No. So next thing, we take in password, validate the password. Phone number, validate if the phone number is correct, as in there are no spaces, no dashes, or the size is correct or whatever. But then also okay, if it exists already, then the user is already there. Just tell them, okay, now you can try with a different phone number or email, whatever. And then we take age, validate the age. We take in gender, validate if it's the string is all right. We take in music genres, and then that's where we call remove dupe word, because we want to remove those nifty front and back spaces at the front and back. Sometimes happens. It doesn't look really good. So I just wanted the raw data in itself, not and without any space in front or back. So trimming those data and then putting that in genres. So basically, remove dupe word is returning a vector of strings. Then we get the bio. We got bio. Then we have orientation. We get the orientation, and we didn't check if the orientation was valid. If it's not, then throw logic error. Then we ask the user, after they've given all of that information, if they're a student. Are you a student? Yes or no? And if the user says anything that is not Y or capital Y or N or capital N, then we say, okay, throw logic error. Please enter a valid response. We ask for Y or N. And if they did put a valid response, then they would have either put in N, which means no, they are not a student, they are a standard user. In that case, we would make a standard user object and add it to the list where we are going to send in later. Yeah, and this is where the parameters are coming from. The magic that has been happening behind the scenes. This is what's happening. We're making a user object, and we are sending in all the details that we have been taking input from the user. We take the first name, last name, email, phone, age, gender, all that stuff, send it to user object, make a user object, add it to the list. But if their response was yes, that they are a student, in fact they're a student, then we need more data. We need their major, and we have to validate that major, like, the input for the major. We have to ask for the school year, expected or graduated. You might be graduated. You're welcome. You can join my app. You can be a part of the database. I don't mind. So we have to validate that the school year is in fact a school year. It's not like something else. And we have to validate school, University of South Florida, or whatever it may be. Maybe University of Colorado, maybe anything. And making a student user object and adding it to the student user list. So this was a student. So this has a different constructor from standard. We've seen that. How is it different? First name, last name, email, phone, age, gender, genres, bio, orientation, then major, school year, school, password, and student. That's how we make a student user, right? So we made a student user and then we add it to the list. And now we have done that. Now we write the new user to the registrants.txt. There we go. We made a user and now we have stored that user in our records. So we don't lose track of that user. We close this app, but the user data is still there. So next time we come in, we still have that user, right? So we tell them, okay, now you have successfully registered. There was no issue with your data, nothing tipped off, no runtime error, no logic error happened. You're good to go. Then we break out of it. We break out of it, and we're saying if flag is true. Flag is only going to be false if they enter X. That is, if they try to exit, we make it false, but otherwise it's true. So we're saying if they did not enter X and they've successfully registered or logged in, this is true, and they'll do something. What is it going to do something? Let's wait. Let's go through login first, because it's the same thing. If you register successfully, you're already logged in. So let's go through login, what's happening in login, and then we can find out what is happening after you successfully register or after you successfully log in. Okay. So if the initial input was not R for the command, it was L instead, which is they want to log in. So ask them for the email and validate their email with regex, and then ask them for the password, validate the password, right? And then we read in the data from the user's file, because we want to check if the email and password is correct and then log them in. So we took in the data from user IO, and we asked to read the data from the registrants file. We said okay, store that in the user list, and then we run through the loop through the list, and we say okay, if we find a pair where the email is equal to the email that the user just entered and the password is equal to the password that the user just entered, then okay, this surely is the user we are talking about in the picture, and you could just say check equal to 1. This is my way of checking if the email and password was correct, right? Check was initially 0, check is now 1. That means hey, they logged in, their password was correct and email was correct, so their credentials were correct. So log them in and add that to the list, add that user at I to the list, and say okay, hey, welcome, you logged in, and then break out of it, and then say if check is still 0, that means they never made it to 1, and that means the credentials they entered were invalid, and then otherwise break out of the outer while loop. Now I know this is not a very safe way, because we're getting password as plain text, while in maybe in Tinder and Bumble they encrypt the data using some SHA-256 or bcrypt or something like that. But let's go with the flow right now. And let's see what is in store for us. So we break out of the loop, and then we break out of the loop, right? And we never came across this scenario where the user entered X or capital X. But basically, let's say if the user did enter X or capital X, then we are saying, okay, the flag is equal to false now. Break. Otherwise, if they did not enter L, did not enter R, did not enter X, then just say, okay, throw a runtime error, you have to input a valid input, man. So that. And now if flag is equal to true, so this is like the only place that flag can become false when they enter X. That's truly when they want to exit the program. If that's not the case, then it must be true. It goes through. It says, okay, now we're getting the latest list of all users. Someone just registered, right? So that list has to be updated. So that's why we are saying again, okay, now we got to read the registrants data from the registrants file again and store it in users again because we have a new user, right? So we make a new user. So we store those users again in users with the updated list, and then we call this friend function, which is counting the number of students which are standard users, or like counting the number of students and standard users, student users and the standard users using the friend function count. Like I told you before, all it does is um, basically increments if the counter for students if the type is student, and increments the counter for standard if the type is standard. So that happens. It then displays the total student users by the getter and the total standard users by the getter for count standard, and then calls the app view. And app view basically uh, app view is basically the method that is calling the app view with the current user, right? So we're sending in the last user. See the last user at the last index. We're sending it in and we're saying, okay, get us the last user, and this is the user we want to show the world. Not the world, but like this is the current user that is what why did I say world? This is the current user that is accessing the app. We send in the app, we send in the user to the app, and this is where the magic is happening. This is all the magic. It's pretty long magic, but let's go through it. User list, you have a bunch of bools, ran once, initial. We'll go through it all in a bit, but let's go through some of these. Again, we do the same thing. We get a list of user from the file. We store the indexes of the user list, shuffled. Why? Basically, we're getting the indexes of the users, but we want to randomize the indexes so that it's not the same every time. We want to have random users pop up. That's how Tinder works, I think. Random people come to you, not the same users again and again. So, and also then we are storing indexes that are already matched, or the people that we have liked already, or the current user has liked already. And temp is holding one user's used indexes. And then like data pairs is a pair of likes for two users, and it's basically calling user IO to read data from the likes file, right? So it reads data from the likes file, and it assigns likes data pairs with that value. So we have the data we need. We have the data of the list of users from the file registrants.txt, and we have pair data from the likes file. Now what we do is we find used indexes. Used indexes is basically the people that have already been liked or have already been matched. So the logic we are using is we're going through the lists of the users, and then we are also going through a list of like data pairs, and we're saying, okay, if the pair's first value is equal to the current user's email, and the list pair second value is equal to the user at i's email, then put that in temporary. That means one pair is found. What about the second pair? What is the second pair? Basically the same concept, A in first column, B in second column, then B in first column and A in second column, which is happening right here. Using temp to find common used indexes and adding it to used. So this used vector is basically what we are going to use. Wow, that was like the tongue trill. But say, yeah, so this logic right here. If the current user.email is equal to the users at I, then we want to continue. We don't want to add that user to the thing, to our list, because we don't want to like ourselves. We don't want to match with ourselves. I mean, As much as I like myself, I don't want to match with myself. I would be terrible for that. So same thing, but now we're saying, okay, the pairs second, is it equal to the current user's email, and the pairs first, is it equal to the user at the temp of I, basically the index at i's at the at ith index of the temp thing, is that uh, equal to the first one. That's basically a little bit complicated to understand, but basically what I'm saying is temp of I. Temp of I is basically the values we got here for I, and then we're saying, okay, users at that index, is their email equal to the first pair, the first uh, the first member of the pair. Yes, that's the way to say it. And then we're adding it to the used vector. So this gives us a vector of all the people that have already been matched with or liked already. And then we're saying, okay, if they are more than if they are more than so this for the matches. So we're saying if we have a size of 1, like if we have like one match or more than one matches, then we got to print the matches. So that's what we are doing here. We're saying, okay, your matches so far are basically, go through the loop. We're saying, okay, if this user email is not equal to the current user, then print the first name, last name, and then the email, because we want to print the email as well. And then we're saying, okay, storing only those indexes that haven't been used. This is the nums.pushback. Basically, these are the indexes that we want to show to the current user to basically go through, because like they do not want to see the people that they have already matched with. What's the point of matching with someone again if you have already matched them? So we only want to show them the users that have not been liked, that have not been matched with them already. So that's how we're getting this. We're saying, okay, current user, same check. We're saying if that current user's email is not equal, if it is equal to the users at I email, then we want to continue, right? And then we're saying, then we're making use of the used vector with the indexes. We're saying if number, we're looping through that vector, and we're saying if I is equal to the any of the number in that vector at any point, we are making our boolean variable initial to true, and we're saying break, and we're saying if initial is true, then continue, right? So that basically makes it so that that index that have been used cannot be added to nums, and only those values that are not in used are added to nums at the end of the day, and we can use that later on. And then we are random shuffling the indexes, because so that we have different users, and that's basically done through the shuffle function. That's an inbuilt function. We're using seed, and that's that. And we are looping through all the users. We're making use of this, getting the index to display the user at. So we're getting the index value with the nums vector we just made at in. In is basically right now 0, yeah, and we increment in at the end of the loop. So we're giving it a random values in nums for the index. And we're saying if this user is liked already, don't show it. So in used vector, we were putting all those indexes that have been matched already. But what about the people that we have liked already? We don't want to like the people we have liked already, right? The same thing with matched. If you're matched, you don't want to hit them again. If you like them, if you have hit them already, but they have not matched with you, still you don't want to hit them again. So we're saying, okay, if we get a pair and we say, okay, the pair's first column A basically, if that's equal to the current email, then and also that the second pair, the second value of the pair is equal to the index, the user at the particular index email. Then we say, okay, flag is equal to 2, and that the user is already liked, it is in the list. Okay, flag was 2, increase the counter for the index in, and then continue. We don't want to display that user. But if they go past here, if flag was false and the person was not already in the likes.txt, then we can show that person. So we're displaying the user cards here. We say, okay, here's someone you might like, and then we are making use of that operator we overloaded to access user at specified index and displaying it to the console. So we are using two operators here. We're using this operator for displaying it with that overloading with the O stream, and this operator for the axis, the squares. And then we're saying, okay, we displayed the user, we're saying hit or miss. We're asking for the input. If the user says H, they want to hit, then we read in the latest like pairs from the file. The latest like pairs from the file, right? We go through the like pairs and we say, okay, we're checking if both parties have liked each other. If so, then we have found a match. So the situation of where in column 1 we have A, column 2 we have B, and in column and then second row we have, or whatever row, sometime we have like column, in the first column we have B and in the second column we have A. Then that would be the case that AB and BA, that means they both have liked each other at some time, so that's a match. So if that's the case, then just say it's a match. Here's the email, because you know what, how would they interact? They have to have the email, and then just say have fun, and then write this pair to the likes file, right? Because let's say the current user is A and the user we just liked was B. This line checked if there was a pair like BA, and it found that there was a pair like BA, and we just did AB, but we haven't written AB yet. So now we are writing AB, and for that's for records. And if it was X, the input was X, then we just return, because remember X is for exiting out of the program. Else if it was M, that means they're missing. They just miss. But if it was not M and it's not X and it's not H, then we got to say, okay, you did not put M, you did not put X, you did not put H. Then enter a valid input, throw a runtime error, and then we just increment the IN, and then we say, okay, ran once. Yes, we were able to run once, run the program once, run the app view once. Now outside the loop, we say if the user has already liked everyone or we ran out of users. So that's if we did not run even once, then that would be the case that if the number of users is greater than equal to 2, then we say, okay, you've already liked everyone, come back later when we have more users. So we run out of users. That's the first case. The other case is that we were able to run, but then also we have like limited number of users. So they went through every user. So we have to tell them, hey, everything comes at a price. If you want to find your soulmate, buy the window dating pass, so you can have access to our premium database where we have like more users or something. So that's basically the end of my app. That's how my app is working. And let's go through some of these small functions really quickly. It sees, removes trailing spaces, uses validate string, and traversing through all data, storing data, strings free. It's used to split string around spaces, validate strings. If character is not alpha, return false. Validate strings that accept spaces. If character is not alpha and is not space, then return false. Validate number and does special check for age. Mode equal to 0 is basically default, but if it's age, then the mode will be 1 in the code above. We're saying, okay, if it is not digit, then return false, because age has to be number. And we're saying mode 1. If it is the age, then we're saying if the age is greater than 100 or the age is less than 0, because it cannot be negative, and I don't think anyone above 100 would come to my app. Then we're saying return false. Then is the email valid? We are using regular expression to validate the email. We validate that email with the pattern. Validate the password. If it is a space, then that's the wrong password, return false. Validate the phone number. If the size is not 10 or if the character is not a digit, then it's false. So that's all that being used to make this application work. That's all the classes and all the functions and everything else. Now is the fun part. Now we get to play through this app. So I've already compiled it on the cluster. Let's run this app. See. Let's see. There was some issue with that, but we can go ahead and compile it again and run the file. Okay, yeah, that works. So yeah, so this is the program view. Now let's try R. See, it asked me for details. So I'm going to register a test user. I'm going to test. I'm saying last name is test user 1. Oh yeah, give me an error because I tried to enter the invalid last name. I cannot have a number in that, right? So let's try again. Register. I'm going to say testing user test 123 at gmail.com. Test phone number will be 000 Age is 21. Gender is male. Music genres they like is rock, casual. Bio is I'm a robot. Orientation is that they are straight. I spelled that wrong. My bad. Are they a student? Yes, they might be a student. Let's say they are computer science because robots like computers. Year of graduation 2023. University of I cannot spell. University of South Florida. Okay, this is successfully registered. Total student users is 6. Total standard users is 5. Hit or miss. I'm say this test user likes everybody. He's gonna hit on everyone. Ah, damn, we ran out of people. Yes, my since my database has only 11 people, we ran out of really fast. So everything comes at a price. If you want to find a soulmate, buy the window rating pass. Yeah, right. But we did run out of people, and we hit with everyone. So what do you think will happen when we try to log in? Well, let's try to log in with test123 at gmail.com. Test. That's right. We have already liked everyone. We cannot like anyone else. Let's not make the same mistake this time. Let's register another user. This one is another user. Another at gmail.com. Wow. I cannot spell another. And we're saying 111, 111, 1111. Age is 21, gender is female. Music genres is they just like rock. I am cool for the bio. Orientation is bisexual. Are you a student? No, I'm not a student. So now we have 6 student users and 6 standard users. So standard users went up by 1 as well. And this user only liked Gonzalez for some reason. They didn't like anyone else. They missed through everyone else. So we just missed through all of them and then we ran out of users again. But this time we log in, right? And we log in into Gonzalez email. Gonzalez gmail.com. Gonzalez. So we logged into Gonzalez and we want to hit on another user we just made. So I'm missing on everyone else because I just want to hit on another user for this test. So we found another user. We write H, and if we enter H, this happens. It says it's a match. Here's the email. Have fun, right? Let's go ahead and miss another everyone else. Let's try and logging in with another user now. So another at gmail.com. Another. See, it says total matches so far. Your matches so far. Gonzalez Cook. The email is this. So it knows that okay, this person matched. So now they both get to see this. How do they see this both? Because like if I log in with Gonzalez now, Gonzalez at gmail.com. Gonzalez. Then they also get your matches so far, and then they get another user. So that is working perfectly fine. They get matches. They get they get matches, and the matches are different for different persons. So like for another user it's Gonzalez Cook. For Gonzalez Cook it's another user. So that the both way thing is working. Let's say Gonzalez also liked testing user, the first user we created right now. So we're gonna find testing user. We're missing on everyone else. Miss on this person, miss on that person. Testing user right there. We hit on them. We miss on everyone else. Right? Then we go ahead and log in. And you can see I missed that, but it's a match. I forgot to say it's a match here, right? I plan to go into test123@gmail.com. We say test and see it has matches so far with Gonzalez Cook. And if we go ahead and log in for Gonzalez, it should have she should have 2 matches now. Gonzalez. Yes, that's right, they have 2 matches now. So that works perfectly well. And if they enter X, it just says bye. So that lets them exit out of the program. So registration is working well for both standard users and non-standard and student users, because I showed both of them. And we are able to log in with the user. We are able to like, which is hit, or we are also able to miss on people. And if we hit on people, then other people that have hit on us are able to match together, and then the match shows for both of them. So that's how my my program works. And if we like everybody, we don't have anyone else in the database left, and we just get a message that we have been liking everyone so much that we don't have any more people to show to you. So that's the working of my program, and that's what my program does. It's basically a console-based Tinder, you know. So that's what it is, and that's how it works. So I hope that this demo was insightful, and that this demo was able to bring out all the flavors that I had in my program, and that I was able to convey all the things that I've been programming with my creativity and my rigor for this project. So I hope that Professor Yu and all the TAs who might be watching this video have liked my work, and maybe play around with my app. And I'm going to upload this online, so I hope people online also play around with my app, and I just hope I can maybe make this better in the future and put this on my portfolio or on my resume. So thank you for this opportunity to let me make this application, and thank you for this class, and yeah, thank you in general. And I hope you like this nifty little project, which is sometimes cute. So yeah, I think that would be it. Thank you so much.